Okay, we're starting this thing called factoring. You may or may not know about factoring, but you're going to know a lot about it after a few days of algebra. The very first type of factoring we're going to look at is this thing called greatest common factor factoring. So you'll hear it referred to as GCF quite often. So in greatest common factor factoring, what you're going to have to do is have a little bit of division and multiplication facts floating around inside your head. We'll do this by a few examples, and I think you're going to catch on. On this very first one, 8x plus 12, my eyeballs would look at the coefficients, the 8 and the 12. And what I want to do is I want to say, hey, is there a number that can divide evenly into 8 and 12? And I know the first number you're going to think of is 2. 2 divides evenly into 8, and 2 divides evenly into 12. So that's good, but we want the greatest common factor. So although 2 is a common factor between 8 and 12, there's something better out there, and that is a 4. So when I look at this first problem, I would say in my head, the GCF equals 4. In other words, 4 divides into 8, 4 divides into 12 evenly, and there's no other larger number than 4 that will divide evenly into 8 and 12. So when I arrive at my greatest common factor, I write it down on the paper, and then I put down some parentheses. And now what I'm going to do is I'm going to mentally divide. 4 dividing into 8x gives me 2x. Don't worry if you're not getting that yet. 4 dividing into 12 is 3. And I put down a plus sign. So at this stage, I really have done my greatest common factor factoring, and I'm finished. But this is probably a little confusing to you, so let's take a look from another point of view what's going on. Anytime I've factored something, what I've done is I've taken this and I've just written it in a different form. And here's how I can convince myself that I'm correct. If I take this problem and I go ahead and I distribute the 4, I'm going to just scribble down here what I would get. 4 times 2x is 8x. 4 times a positive 3 is positive 12. That 8x plus 12 matches the original problem, which confirms that I've factored this correctly. So 8x plus 12 in factored form, using a GCF of 4, is 4 times 2x plus 3. I confirm that I'm correct by doing the distribution back, and this makes me happy. Now I know that I'm correct. So when you look at greatest common factor factoring, it's going to occur often, but not always. So if I skip this one and I go to this one, I would say, what divides evenly into 10 and 20? Well, 2, that does. 5, that does. But there's something even better, and in this case, that something better is a 10. So if my GCF is 10, that's what's floating around inside my head. I put down the 10, and then I put down the parentheses. Now I say 10x divided by 10 leaves me x, but another way to look at it is this. If I think about that, I'm eventually going to have to check myself and distribute the 10 back to make sure I get what I started with. That's what was happening over here. Then I can kind of daydream and say, what would I have to write right here to make 10 times something equal 10x? And that something is x. What would I have to write right here to make 10 times something equal 20? Well, that something would be 2. And so I do 10x plus 2, and like I said before, I can check myself by distributing back. 10x plus 20, that makes me happy. I know that I have done a successful factoring. I've done a greatest common factor factoring. Here's a case where there is no number other than 1, and 1 doesn't really count for a case like this. There's no number that will divide evenly into 3 and 7, so I could say not factorable. So I'm always taking a look at a problem and saying, is there a number that will divide evenly into both of those terms? Now choose the largest number of those, and I can write it in factored form. Here's an example of something that's written as a binomial and then rewritten as factored form. And basically, I can go this way, take this original problem and write it like that. That's called factoring. But in a different situation, we could just literally go this way and return back to the original problem. In other words, think back a little bit ago, we said, let's see what happens if we distribute this 5. If I take this as an original problem and do my distribution, I get 15x plus 25. So notice how if I go one way, I'm factoring. If I go the other way, I'm distributing. We're just basically learning how to work with binomials in factored form, going one direction or the other direction. It just so happens today we're focusing on factoring, making this problem look like that, and earlier you would work on distributing or multiplying, making this problem look like that. These next 3 questions give you a little bit more to think about because now your GCF is going to involve a variable. So this is a very important point. A GCF is going to include the variable with the least exponent. So here I have an exponent of 2, here I have an exponent of 1. So I have a GCF of x to the first power. I know you probably wouldn't write that x to the 1. And now I need to know what am I going to put inside here. Well, I'm going to put an x, and you could put the first power if you want, plus 4. And that's going to be my final answer. But how did I know to do that? Well, one way to think about it is I took my x squared, my original piece, and divided it by the common factor of x. I took my 4x, the original term, and divided it by my common factor of x. This divided by that will leave me that. This divided by that will leave me that. But if you don't like it, you can do, or if you don't like that method, you could say this. If I have an x out here, what do I have to put underneath my finger to make that distribution work? X times some mystery piece gives me x squared. That better be an x. X times some mystery piece better give me 4x. That needs to be a 4. So it gets a little bit tougher thinking when you have variables instead of numbers. So I take a look at this one, and there's no number that will divide evenly into 3 and 7 other than 1, but I have common x's. So what I'll do is I will choose a GCF of the smallest exponent of those two. Now I need to figure out what goes in here and here. Remember, I can do this, 3x to the 4th divided by x to the 3rd, 7x to the 3rd divided by x to the 3rd. But another way to do it is just kind of daydream what needs to go here so that that first swoosh of distribution would work. That would be a 3x. This times this would leave me that. And a 7 goes there. Here's my final answer, but I know that's also correct because if I go ahead and just distribute out, this distribution confirms that I'm back at my original problem, and that makes me happy because it tells me my factoring is right. Right? I take a look at this one. I have x's in both terms, so I choose the smallest exponent. And, oops, that's supposed to be a minus 1. Okay, and how do I know this is true? If I multiply this times this, I get x to the 5th. because when I multiply, I add exponents. When I multiply this times this, I get that. So that makes me happy. That tells me that this is a correct factored form. By the way, we're going to find out later on in our factoring that we could go further on this problem. We're not worried about that right now. And these last three are examples where you have variables and coefficients in your GCF. So when I look at this problem, I would first say, what's a number that divides evenly into 6 and 12? And what's the largest one? That's a 6. 2 and 3 are also good ideas, but 6 is better. Then since they both have x's, I choose the x with the smallest exponent. So my GCF is 6x squared. I'll have to go back and figure out what now goes into the parentheses. But let's use that same logic on this one. I have a 5 and a 10. A 5 is the GCF between a 5 and a 10. It's the biggest number that divides evenly into both. I have an x to the second and an x to the first. X to the first is the GCF. You don't have to write that one. We'll figure out what goes inside there in a moment. In this third problem, I have a 14 and a 21. What's the largest number that divides into 14 and 21? It's a 7. Both of these terms have x's, so I choose the lowest exponent, x. And now I have to figure out what goes inside there. Remember that what goes inside here could be a division problem, so I go ahead and say 6x to the third divided by 6x squared. You can do that, or you can just ask yourself, what goes in here so that when I do my distribution to check my answer, it works? In this case, x, because 6x squared times x gives me 6x cubed, and 2. If I do that distribution, I find out that I'm correct. I get a 6x cubed minus 12x squared. That makes me happy. Over here, I would need an x, and I would need a 2. 5x squared minus 10x. That makes me happy. And over here, what needs to go here to make this first distribution work? I need a 2, so that 7 times 2 gives me 14. And I need an x to the 5th, so that x to the 2nd times x to the 5th equals x to the 7th. What needs to go here to make that second swoosh work? I need a 3. 7 times 3 is 21. And I don't need any variables because 7x squared, if I put an x here, my exponents are going to get too big. So I am done right there. If you take a look at our entire sheet, we went from very simple GCF factoring with just coefficients to think about. Then we thought about what happens if there's variables. And then on these last three, we thought about what happens if there's variables and numbers combined. So this is our very first step of factoring. We will always say GCF factoring is the first factoring you should think about, even though we're going to learn a bunch of other factoring techniques.